Yeah, let's use this to be sure we are good with the microphone. Still don't hear anything. Okay, so now the microphone is set up correctly. So it should be the right one. Okay, so we start. Everything looks correct, ready. Yeah, looks like I have a warning. Shows that the stream bitrate it's not a good one, so I'll need to change it. So yeah, I don't really like to do that on stream, but what can we do? So we have output, bitrate, it's set up to this 68. Apply, okay. I'm not sure if that's the right stuff. Yeah, let me check. Yeah, maybe the warning open widget. Okay, should be fine now. Let's start solving our problem, because this is what we are for. So let's create another mod. So here we'll have randomized set. Yes, with all one. Yeah, I don't know how to write it better, but it doesn't really matter. Okay, let's go inside, paste it, realign it. So yeah, for insert and remove, for sure we'll need mutable reference. What else? For solve, here we'll just need to initialize. So I'm thinking now what data structure we can use. So what option do we have? For sets, having O of 1, if we're talking about O of 1, there is literally one data structure which comes in mind. Actually, two data structures which comes in mind. It's either a hash map, which will allow us to insert and remove items in O of 1. They'll get random. Yeah, about the random stuff, that's a little bit tougher. Should be okay, so let me move this on this side. I want to move this on the right side, and now we'll have everything in the right order. Returns a random element from the current set of elements. It's guaranteed that at least one element exists when this method is called. Each element must have the same probability of being returned. So if we're talking about probabilities, then kind of need to use a random module. Acceptance rate of this one is 54.1%. So it looks like it's not necessarily an easy problem. Yeah, I am still receiving that the bitrate is lower than recommended bitrate. Trying to fix it somehow. Yeah, let's see, how can we fix this? So we have stream, we have output, streaming, bitrate, GPU. So I've set here encoding settings, streaming advanced, output mode. So if we switch this, okay, so let's try that. Maybe we should increase it even more. 50,000 maybe. What happens if we apply this? Tuning high quality, multipass quarter resolution, hotkeys. Yeah, looks like this didn't help. Apply, okay. So if we go with not advanced mode, what's this about? Does this change the quality of the stream? Lossless CBR. High quality, keyframe, advanced. Yeah, looks like I cannot change streaming service bitrate settings. So bitrate, and I need to increase that. Yeah, let's try to put 10,000. I don't know. I don't like this warning. Yeah, I guess we have some production issues. Yeah, I'll check, I guess. So we have a different bitrate, and I'm not sure how I could change that, but I'll use some off-stream time to do some investigation to try to fix it. Yeah, so let's get back to our problem. So concerning this, we have like two possibilities. Either we use a vector, and we'll have, because as we can see here, it's expected to have values, I32 values. But the problem in the I32 values is that we'll need to have from minus I32 max, min, or from I32 min to I32 max. Sorry about that. And this implies like a couple of trillions of values, so it's not really possible to initialize such big vectors. So we'll try to use a hash map for that. So we'll have a hash map, and we'll use to store the values as keys. And we don't really care about the values themselves. I mean, yeah, that's a little bit unclear because 2 multiplied by 10 power 5. Oh, constraints. So that's the value. Okay, so value at most 2 multiplied by 10 divided by 5. Calls will be made to insert, remove, or get random. So somehow they mentioned a constraint here. Because if you try to use a hash map, probably it will work, but doesn't make a lot of sense. So maybe what actually they want from us, it's to create as a vector, and we'll have here like 2 multiplied by 10 and let's say 200,000 indexes. This is what I mean. So we need somehow a hasher function which will store for every value. But what should the value start with? That's an interesting thing. Because if it's set or not set, nah, yeah, that's tricky, literally. Yeah, so let's keep on working on the hash map part. For now, I don't have any other solution for this. So we'll have it a pub data. The key will be I32, and the value will be a boolean. It could be anything literally, because we'll not care much. But should be good enough. Okay, so let's create a new data. We'll have like a hash map new. So we have our new set. Inserting. So we'll do self.data insert, and we have the key, which will be val, and the value will be true. I guess we'll just use true. I don't really understand why this should be a boolean. What should we return? Insert an item val into the set if not present. Okay, so there is some logic. So we need to check if it was present or not. So yeah, we need to write something like that. If cell data contains key val, we'll have true. Should we return to if the item was not present? Okay, it should be false. Else self.data insert val true and return true. Yeah, this should be a reference. That's correct. So we've implemented the first part. Let's do remove. Yeah, we don't need this terminal for now. Remove an item val from the set if present, returns true if the item was present, false otherwise. So we'll do this. If that, we'll do data.remove val, and we return true, else we return false. Remove an item val from the set if removes an item val from the set if present, returns true if the item was present, false otherwise. So we remove and return true and false otherwise. So for the case when we have like get random, so for this we kind of will need to use rand. So probably we'll need to add cargo add rand. I kind of forgot a little bit the syntax, but what we'll need to do, it's yeah, probably we'll need to so get random also should be of 1. It's guaranteed that at least one element exists when this method is called. Each element must have the same probability of being returned. So get random to be of 1, that's interesting. Because we need to know at runtime at least how many of them they are. And then we'll be able to pick one. Okay. So let's try to see first. I'll need to rustlang rand. I think we'll need to generate a thread, and we'll need to generate 0 and 1. Rand from range. Okay, gen range. Yeah, that should be good enough for me right now. So we have rand. So let's use rand. RNG. Okay, range. So we have from 0, but actually in the definition it's told that we have at least 1, but we'll need to know as well the length, how many items there are. I guess we can get the value from how many values are there by using the command will be self.data.length. So we have the number of items. We'll get a value like an index. And now we'll need to get self.data. Unlikely this will work though. So probably we'll need to do iterator. even not like this, but just get. And you'll need to provide the index, but maybe keys. Get. Skip. Okay, so we'll have keys. Keys will be what will be keys? Is that an iterator? I think it is. Let's go. So skip looks like it's an iterator. Yeah, so skip looks like it's an iterator. It's an iterator. Then we'll skip num or index and take one. So assuming we'll take the first one or just first. No, this doesn't work. Take one and let result. Just want to see what this returns. Okay, so we'll need to take one. Guess we'll need to collect. What? Oh, so we cannot do it like that. Then we'll need to unwrap. What's no, we need to collect. And what we'll be collecting then? Result. A value of type i32 cannot be built from an iterator over element of type reference of i32. Okay, so then we have keys which are references. Then we'll need to map x. We'll need to dereference in this case. We cannot collect. We can collect. So we'll have result, or not result, but back. And then here we'll have result of 0 because we are taking 1. So looks a bit ugly, though I have a feeling it should work. Yeah, let's try to run this code and see does it work or not. So let's run it first and see how do we do. Okay, so we have some compilation errors. Range use size. cd ops 1 len. cd ops range use size. Okay, so it looks like we need to do something. I'm trying. Range use size. Yeah, looks like here, gen range. Oh, I don't need a range actually. Oh my god. So yeah, let's get back to Rust. Task RNG. Yeah, so we'll need distributions as well, and we'll need to have like a uniform distribution. Yeah, probably like this. So probably like this. Okay. So we have len uniform. We have this. We start from 0 to len. We have a sample, and what's the trouble? RNG core. Use ran distribution. Okay, so we need to use this trait. Okay, use rand, distributions, and distributions. So we need to include this trait for this to work properly. Okay, so now we have our range, we have our choice, which is our index. We'll skip everything to allow our index, and we'll take 1. So this should work. Let's try to run it. Okay, this works. Runtime 0, submit. And we have 21 days completed, which is pretty good, though our solution is not the fastest. Yeah, let's see what's the fastest part. Yeah. Interesting. Wrap. So we have items, and we have item to index. So we store the items, and as well we store the item to index values. But I do not understand why do we need to do that. Probably for get random. Yeah, in order if you want to have like a get random, fast get random stuff, then in this case we can use like thread RNG, and we can use this approach. What I did, I used a little bit different one, and this actually it's not of 1, but still they accepted it. Because worst case scenario, if you want to get the last, we'll iterate through all the keys, and we'll just get the last. So that's it's not a correct solution. So yeah. Yeah, that's not the correct solution, but yeah. This stuff which the first guy added, that's a correct solution. Because literally get random in this case, it's O of 1. So a pretty smart solution there. Anyway, okay, so let's get back to our easy problems. So we solved the problem of the day. So I have a streak of 21 days, which is really, really nice. So even Saturdays, Mondays, Sundays, and all the other days. So I have 69 out of 762 easy problems solved. And during these streams, we'll continue solving easy problems. we've got to page 2. I see a little bit. Okay, so I've changed to 100 on the page. I remembered I had like okay, so yeah, cool. Yeah, let's check this one. I think I opened it a little bit too many times. Yeah, let's check that one. Left and right, some differences. Given a zero-indexed integer array nums, find a zero-indexed integer array answer where answer length will be equal nums length, answer I equal left sum I minus right sum I. Kind of don't really get it. Yeah. Left sum I in the sum of the elements to the left of the index I in the array nums. If there is no such element, left sum I equals 0. Right sum I is the sum of elements to the right of the index I in the array nums. If there is no such element, right sum I equals 0. Return the answer. Yeah, this seems a little bit interesting. Yeah, let's check the constraints. So nums will be 1,000. So we can have 1,000 numbers. Acceptance rate is huge. The values of I will be 10 of 1,000. That's not a problem usually. What else? We have a couple of topics here to, for each index I maintain two variables, left sum and right sum. Okay. Iterate on the range j 0 I minus 1 and add nums j to this left sum, and similarly iterate on the range j I plus 1 nums length I length minus 1 and add nums j to the right sum. Yeah, it's a little bit interesting. Yeah, so for this kind of problems, what I like to do is get on my whiteboard and try to solve that example and try to understand what's the algorithm in itself. Flame shot. So need the flame shot part. Let's take a screenshot. Yeah, I'll need to do it like this. So let me take this screenshot. Get here and try to solve this. Okay. So we have the nums number. The array left sum is 0, 10, 14, 22. Wait a second. Where did we get this part? Because it's not clear for me. So if we are here, left, index 0, what's left of index 0? It's 0, because we don't have anything. We are here. What's left of 4? It's 10. Okay, that's clear. If you are here, what's left of 4? It's this 2. It will be like 14. If we are here, what's this sum including? It will be like 22. Okay, so that's interesting. We got our left sum. And kind of we can do this in one go, in O of n. We solved another problem which pretty much does it. Yeah, we may have a little bit of troubles on coding it, but should be fine. And on the right side, let's check the right side and how we can do that the easiest possible way. Maybe we should revert it. So instead of writing it not like that, but we can try to go in reverse order. So like 3, 8, 4, 10. So we reverse it. And then we go the same algorithm. If we're at this index, the result will be 0. If we are at this index, the result will be 3. If you are at this index, result will be the sum of these 2, which will be 11. If you are at this index, we'll have sum of these 3, which will be 11 plus 4, it will be 15. We'll need to reverse it back, and we'll have like 0, not 0, it will be like 15. Uh, 11, 3, and 0. So let's compare with the results. 15, 11, 3, and 0. Okay, that's cool. So reversion, it's O of n. And we do another O of n for this operation. And then output, what we'll need to do is modulo, so it will be like left. Okay, so we have this left. Where is left? Yeah, let me write it. So we have like a 0, 10, 14, and 22. And the right one will be where, yeah, this was left. I assume, yeah, this is left. And this will be right. And right will be like 15, 11, 3, and 0. So if we do our math operation. Oh, hello, Mohammed. What's up? It's not the bad scenario. Not sure I got it. What's up? What's up? I'm doing good, doing good. So just trying to solve a couple of problems on LeetCode, trying to understand though what's the algorithm for this one. I'm thinking how to code it. But I didn't get your second message. It's not the bad scenario. Can you elaborate a little bit? I didn't get it, sorry. Okay, so hope Mohammed will answer. Yeah, welcome, by the way, on the stream. That's really cool that I'm not alone here. Yeah, anyway, so this we can zip, and we can do our absolute values, and we'll have like 15, what will be like 4, 11, and 22. So is that our response? 15, 1, 11, 22. Oh, yeah. 10, 11, it's 1. So that's correct. So overall, we've got okay, because the O n log n is better than O of n. Ah, no, it couldn't be better because n log n means n, which you multiply by log n. So if this is a number and log n is another number, it always will be bigger than just n. So n log n, it's I guess log n will be a logarithmic complexity. N will be a linear complexity, but n log n will be a linear multiplied by logarithmic. So this is done usually by recursive functions like sorting functions, and this means for every scenario in n, you'll have a log n other operations. So n log n is not better than O of n. Oh, log n. Okay, yeah, log n is better, but why that should be log n? Because why that should be log n? Is it told somewhere that this is sorted or something? Yeah, let me check that. Yeah, log n will mean that we'll do like some sort of a binary search on the items, but we still need to do the sum of all elements. So we can use a recursive thing. Yeah, we can. But still you'll need to call the recursion n times, or let's put it specifically n minus 1 times, because you will not need this. Or maybe I'm confused with something, I don't know. I need to see the code, and probably I'll tell a different thing. We can use a recursive thing. Let me try to think how. What will be our recursion? And why do we need a recursion for that? Binary search. But for what, literally? I don't understand for what. Because in any way, in order to get a sum of all elements, yeah, so let me move a little bit down. Yeah, probably here. So in order to get the sum of 10, 4, 8, and 3, so imagine there are more, like 5 and 6. Let's put a couple more. For left, once you are at this index, you'll still need to get the sum of every other element here. And if you are at this index, you'll still need to get the sum of every element here. And if you are at this index, of here and here. So in the end, your recursion still will be called like n minus 1 times, which will be still O of n. Actually, it will not be even O of n, but if you use memoization or something like that, yeah, probably it will. We can get to O of n, but we don't need we don't need to complicate ourselves in such a manner. Okay, so I think I figured out what we'll need to code. It's pretty straightforward. Let's try to write it down then. So yeah, first we'll need to get the left sum and the right sum. Do I need, can I use it here? Probably yes. So let me try to write a function. So let me try to write a function like which will be summing. We'll have our nums, which will be a reference of a vec of i32, or we can write it like this. And we'll return a new vector of i32. Okay, so given we have nums, now what we can do, we learned this the last time. So we'll do an iter once. I think it's in std collections. Not std collection, but std iteration and once. So we'll have like once. We'll start at 0 because we know that we need to start at 0. Then we'll chain. And inside the chain, we'll do a num scan. Our starting point will be 0, and then we'll have our state, which will be a mutable state. Though we'll need to make sure to not include the last one. That's the tricky part. But okay, got it. Then we'll do like iterator, and we'll do skip, not skip, but take only nums dot len -1. We don't want to get all items, but we want to get only some of them. We're not some, but everything minus the first one. Minus the last one. Yeah, sorry about it. So we have our item. Then we'll do like state will be summing plus item. We'll return a sum of state. So we'll be chaining all of those. And then we will collect. And we'll collect the response. Okay, so we've got our function, which will do the sum, left sum, right sum. As you can see here, this function of our will has a complexity of big O of n. So O of n, so or linear, because it will be called like n-1 times, though it's ignorable. So yeah, so still it's big O of n. Okay, so we've got our sum function. Now we'll need to generate like left sum. Let left sum. And then this will be like sum of nums. This will get us nums part. Then for the right sum, we'll need to mutate it and have it in reverse order. And then this will be like nums I don't know if that's the right syntaxes though. I don't know if that's the right syntaxes. We'll check it. I don't think it's possible to do that because we'll need to have like a mutable variable. So something like this, let mutable write sum, let mutable nums, which will be nums, and then we'll do like nums reverse. We reverse nums, and then here we'll insert nums. And then we'll need to reverse again, write sum reverse to get it back in the right order. So now we have like our sums. So we have left sum iterator, and then we will use the zip function. And we'll do a write sum iterator. And we'll return our map, which will be a tuple of left and right. And we'll do like left minus right ABS. But I think both of them will be both of them right will be references, so we'll need to make sure to dereference them in order to sum. And what we'll need to do is to collect the end result, and that should be our solution. Yeah, very likely I have a bunch of issues, so let's try to compile first, as expected. Okay, once, iter once. So it's not iter. Yeah, I don't know what's how can I do that? So iter not here. It's std iter once and value, so that's correct. std iter use. I forgot the use. Once. So first compilation error solved. Second, yeah, I wrote a little bit of TypeScript today, and the syntax got different. Write some, yeah, that's not right. That will be correct in this way. So write some iterator. Let's run again. State is immutable. Cannot borrow state as mutable. Why? Because we need to send like a mute. It's not declared as mutable solution. What do you want? Oh, so first it shouldn't be a reference. That's right. It's just a number. Okay, so yeah, we cannot use item will be. But yeah, if just a number, that's a little bit weird. But I assume item will need to be dereferenced. Yeah, welcome to Rust, guys. You can write the code, you have the idea. Oh, so we'll need to dereference state as well. So state, it's also an and then we'll need to dereference the result of this stuff, if that's the case. Okay, so finally, we solved it. So yeah, we have like, if we do an analysis of our code, so this part will be open. This part will be open again. This part will be space open because we do a clone here. This part again will be open, and this will be again open, and this will be again open. And we have like, if we'll not include the space, extra space, which we'll need to solve the problem. For extra space, we'll have like 3 open. So 3 times more the size of our nums vector. And the complexity will be like, and time complexity will be like 1, 2, 3, 4, 5, 6. So 6n. Which, if you do like a big O notation or asymptotically, this means 6 will be a constant and still will get an O of n result. And the extra space as well of n. So we can call this a pretty optimal algorithm. I'm still thinking on why Mohammed mentioned about of log n, because I'm trying to figure it out. I do not have an idea why this O of n will be possible here, log n. Yeah, let's check another solution. So yeah, same approach, scan, reverse, right, reverse, zipping. So exactly the same algorithm, exactly one on one. So it's, but this is written in a more, in a cleaner form. So accumulator, but it doesn't do the chaining part. So I'm trying to figure out why. Because for me, that's a little bit unclear. I've tested the last time, and this was not the case. So first value, which we'll set, it will not be a correct one. So how does it manage to do that? Because I have a little bit more operations here. For example, I take nums len -1 and chain to include 0. But I did not see here how this guy includes 0. So yeah, it does the reversing part, which I did as well. So yeah, he iterated them, he reversed, he applied the scan starting at 0. Item does exactly the same operation as I do. Does the ABS part and collects the response. So yeah, overall it's the same idea. Same idea. Maybe code is written a little bit differently. Mapping part, he wrote it in one go. But I guess, yeah, 1ms, 2ms here will be the same. So memory-wise, it's the same. Everything else is the same. So yeah, this one was a little bit more work than I expected. But allow one function call. Yeah, let's see this one, what it is about. Wait. Yeah, this is JavaScript. We don't do JavaScript today. Yeah, let's check this one. Find the corresponding node of a binary. Yeah, this seems like C++. Yeah, we don't do C++ either. Count of matches in a tournament. I feel like this will be MySQL, but let's open it to be sure. No, it's not MySQL. That's that's Rust. Cool. So we do have another problem. Yeah, let me clean my board here, as we'll not need it anymore. Count of matches in a tournament. You are given an integer n, the number of teams in a tournament that has strange rules. If the current number of teams is even, each team gets paired with another team. A total of n divided by 2 matches are played, and n divided by 2 teams advance to the next round. If the number of teams is odd, one team randomly advances in the tournament, and then rests gets paired. A total of n minus 1 divided by 2 matches are played, and n minus 1 divided by 2 plus 1 teams advance to the next round. Okay. Okay, so I guess here we'll need to do a loop, and that should be it, I think. Yeah, so let's start with n. So we can loop it, or we can do like while n greater than 0. And we do something on the following lines. It will not allow us to change n. Yeah, let's clone this variable. Yeah, odd or even. So let's write a code for odd. If n divided by 2 equals 0, this means it's odd. And then this, yeah, we'll need matches. Yeah, that's a problem for starters for sure. Then we'll do like matches, where yeah, before we'll do like n divided by 2, n will be equal n divided by 2. Matches plus equal 1. So we did a count. We increment our matches. Else, not else, but here we'll return our matches. Or probably we should call it matches count. Okay. Matches count. If else, if it's not equal, then n will be n minus 1 divided by 2 and plus 1. And matches count plus equal 1. So this repeats in both cases, so we can remove it. Let me double check. I think that should be the entire algorithm. So if n is greater than 0, once we got to 0, where it did go negative, but it cannot, because division by 2 on 1. But yeah, maybe here we'll have like a recursion. 0 divided by 2. plus 1. Yeah, here we may have some troubles with the last element. Time limit exceeded. Yeah, we have a cycle. The cycle, it's for the last one. So let's assume we have the following example, 7. Okay, number of matches, 3, 2, 1. Oh, so we need to count matches, not rounds. Oh my God. Okay, so matches count. Then we'll have matches will be yeah. Yeah, let me do it like this to be clear for me. So we have teams and matches. So if teams is divisible by 2, then matches will be plus equal teams divided by 2. And then teams yeah, probably we shouldn't do this 2 times. Yes, teams will be equal teams divided by 2, and then we'll sum our teams. Matches plus equal teams. For the second scenario, if it's not divisible by 2, for the second scenario, if it's not divisible by 2, it's even in this case. It's odd. No, it's not even. It's odd. One team randomly advances in the tournament, and the rest gets paired. So this will be the sum. So where in our case will be matches plus equal teams divided by 2, but not like this, but teams minus 1 divided by 2. But teams will be equal teams minus 1 divided by 2 plus 1. Okay. So let's check example again. So for 7 divisible by 2, no. So we do matches will be 7 minus 1 divided by 2, which will be 3. So at this level we have 3. And teams will be 7, 4. Like 4. So teams will be 4. 4 divided by 2. And then here will be plus 2 again. 2 is divisible? Yeah, it is. So it will be 1. But wait a second. Because 2 divided by 2. Yeah, I'm a bit confused. What's going on? Two divided by 2 will be 1. 1 match. I guess if it's 1, but not n in this case, it will be teams. Is greater than 0. It's greater than 1, because if we got 1 team, this means we have a winner. So we should exit our algorithm. Yeah, it's not matches, it's matches count. Yeah, again, here. Awesome. So looks like we solved another one. Cool. So yeah, pretty straightforward. This one, not a lot to discuss. Let's move on. Let me refresh the page and see where did we stop. Okay, let's move on to splitting a string in a balanced strings. So balanced strings are those that have an equal quantity of L and R characters. Given a balanced string S, split it into some number of substrings such each substring is balanced. Okay, so when we have this type of problems, I feel like they are easily solved using a stack. Maximum number of strings you can obtain. So yeah, we're gonna need to know the maximum. So is that a dynamic programming? Greedy counting. Oh, okay. Yeah, by looking at the hints and topics, they expect us to count the number of L and R's. Okay, let's check. Loop from left to right, maintaining a balanced variable. When it gets an L, increase it by 1, otherwise decrease it by 1. Okay, so L 1, 1, 1, 1 balanced. So if it's 0, then it's this means we've got but we know that's balanced string. So what we'll need to hint to, I guess we need to store the max one. Whenever the balance variable reaches 0, then we increase the answer by 1. Yeah, I mean, yeah, it's the same approach. The other way is to do a stack with complements. But that's actually a cooler solution. So yeah, let's fastly code it. So we have S chars. We'll do like for char gh in S chars. We'll do match gh. Let's do like a let mutable balanced counter. We start at 0, but not at 0 actually. Yeah, let it be 0. So we do match char. If it's an L, then we'll do balanced counter plus equal 1. If it's an R, then we'll do balanced counter minus equal 1. If balanced counter plus equal equals 0, and then we have a match. Let's call it okay, let's do like this. Let mutable matches wherever. Let's use the variable naming from the last problem. We'll do like matches plus equal 1. I guess what I do here, I am just coding exactly what they want us. So we loop from left to right. Let's call this balance, just balance counter. So we have like a balance counter. So we'll have like another panic here, invalid char. We'll need to cover this for this to compile in Rust. Well, yeah, we kind of need to, so what's the trouble? Yeah, we'll need to surround it by a body for this to be valid. Yeah, how about now? And yeah, we'll need to return matches. That's our expected. Expected because of return type. Yeah, that's right. Zero. Okay. So we do R. So if we do R, yeah, let me check again. But actually it's not necessarily to be L first and R first. The Y's decrease it by 1. Yeah, I do that, but it doesn't seem to work, so. Yeah, for this case it works. But for this case, so we have R, we'll have -1. So we'll have -1 here. And then the next stage will be S. Yeah, and here we'll need to do the same thing actually. So, because this works as well. And probably in this case, we'll do it like that. To not write it multiple times. So we do this, and we do this, this. We try to, yeah, this unfortunately it's not properly. Not sure if this will allow us to do. Probably not. Yeah, let's see if this works, then we're good. If not, then we'll just do the brackets. Okay, so it allowed us. Yeah, simple, straightforward, nothing fancy here. If you have troubles on solving it, you just read the hints. As well, topics, it's a good way. By looking at the topics, you can have a suggestion on what the algorithm should be. So hints and topics will give you tons of information on how to fastly solve this problem. So yeah, let's check if this compiles. Yeah, indeed it does. And we are in the first place actually, but not with memory. I don't know why. Yeah. Chars of I. Collect. Okay. Same algorithm, so nothing fancy new thing. Okay, let's go next. Our goal is to solve as many as possible. So create target array. nums vec_i32 index vec_i32 and vec_i32. So create target array in the given order. Given two arrays of integers, nums and index, your task is to create target array under the following rules. Initially, target array is empty. Okay. From left to right, read nums I and index I. Insert at index I the value nums I in target array. Oh my freaking god. Oh. Okay, so they are same sizes. Yeah, this is a simple problem. Just it's the confusing thing here. It's how it's written. But okay, I assume all of them have exactly same size. So target array is empty. Okay, so let's look at the constraints a little bit. So less than 100. Index 0, index I is less or equal than I. Didn't get more information than what I initially had. Yeah, let's go slowly and try to understand. Looks like my head, I'm not thinking as fast as I would like. Though let's try to understand what's expected from us. Initially, target array is empty. Okay, we can even create an empty array. Target, which will be an empty vector. I think we can even try to initialize it with zeros, and we have like nums len to be sure that all the indexes are created. So I assume here we have 5 elements, all of them will be zeros. Anyway, we'll reassign them. So we shouldn't care much about the values. Any value will work here. So 0, it's just a good starter. Yeah, welcome everyone who joined. I see a couple of people in the chat. So if anyone wants to tell where are you from, guys? What's your goals? How did you stumble upon this channel? Would gladly answer. Okay, so we have this from left to right, read nums I and index I. Yeah, I guess we'll have an index. Let mutable index. Mutable index. Even we may not do it like this, but we can do a for loop for index in 0 nums len. Yeah, this I see it's repeating, so maybe we can extract it into a variable, but we'll optimize it a little bit later. So from left to right, read nums I and index I. Insert at index I the values num I. Okay, so insert at index of index I the value nums I. Okay, so I guess target dot index of index will be equal to nums index, and then return target. So yeah, this problem is nothing more than just confusing. Kind of indexed by I32. What? View size. Okay, yeah, that's right. What? Okay, so index nums 0, index 0, target 0, nums 1, index 1, 0, 1. Index 4, index 3, we have the value 3, and the value will be 4th. Okay, so here we have I don't really understand what's because we have like indexes 2, 2, and in this case it's kind of correct. Again, from left to right, read nums I and index I. Okay, so we do that. Index I and num I. We can do this nums I will be nums index, and let index I will be index. So we have these two elements. Insert at index I, the value nums I in target array. Oh, I don't get it. Oh God, I don't get it. So yeah, let's see. But index of index I, it's 2. But 2 should be here the value then. What do they want from me to do? I mean to just... Okay, so 0, 0, that's clear. Nums 1, index 1. So element at index 1, it will be nums is 2. Index 2, we have 2. Nums is 3. Index is 2 again, so we put 3 here. But we move 2 on the right side with one element. Oh, I see what's the trouble here. But they didn't explain this. I mean, that's kind of very weird problem. Retro nums I. Insert at index I, the value nums I in target array. They didn't mention anything about shifting. I guess there is a function in Rust, though I forgot the name. We'll need to insert at I think that's called Rust vector insert art. I think that's is empty insert art. I think that's the name. Oh, insert position a new element. So it's still insert, but we'll provide the position. Okay, that's fair. So instead of this, we'll do target insert position will be index of index as usize, and element will be num's I, num's index. Guess that should do it. Insert. Yeah, here I see it's inserted just the values from index. Wait, then what's I don't get it. Yeah, let me check here. So we'll have like back. Index usize and element t. So actually we are correct. So insert index you can do like let new index will be index of index as usize. So new index nums of idx. But I don't understand why index and output. Ah, yeah, kind of it's clear now. We don't need to do that. So looks like it shifted everything else on the right side. So yeah, we kind of do not need this extra variable. Yeah, that was a cool problem. Let's submit this one. So we're up an hour and 35 minutes. Pretty good. We managed to solve a couple of problems. Yeah, let's check this one. And maybe we'll do a couple more and we'll be good for today. We're given a list nums of integers representing a list compressed with run length encoding. Consider each adjacent pair of elements. Frequency value will be equal nums2 multiplied by I, nums2 multiplied by I plus 1, with I greater or equal than 0. This seems more like a binary tree of this structure. Okay, so for consider each adjacent pair of elements. For each such pair, there are frequent track elements, frequency elements with value val concatenated in a sublist. Concatenate all the sublists from left to right to generate the decompressed list. Yeah, so this one, it's more like to understand what in the world they want from us. So we'll spend more time into understanding the problem itself than yeah, we'll need to decompress. So the first pair, okay, so we have nums, which will be a vector. So the first pair, 1, 2, means we have frequency 1 and value 2. So we generate the array 2. The second pair, 3, 4, means we have frequency 3 and value 4. So we generate 3 4s. Oh, kind of, it's clearer. So we'll have like 1 ones and 2 3s in this case. Okay, so yeah, it's pretty straightforward. And in order to do that, I am always confusing it, but we can do chunks. We can do chunks 2 by 2s. Or windows, I forgot. So chunks, I'll need to check the documentation for chunks. Rust iterator chunks. Yeah, let's run this. Yeah, that's cool. That's cool example. I mean, show what does it return, guys. I can run it, but what's the slice chunks? Okay, so that's more like it. So we have LORE. So if you do Windows, it's a bit different approach. So yeah, in this case, we'll need chunks. Okay, so we'll need chunks will work for us. So we'll do nums. We'll do iterator. Then we'll do chunks of 2. Then we'll do a mapper function where we'll have a result, or let's say item, and we'll have a frequency will be item of 0, and value will be item of 1. And what we can do is return a vector of value and frequency. But this needs to be a new size. Once we do that, we can flatten and we can collect. And this should return our result, I think. Yeah, pretty elegant solution. If this works, I like it a lot. Yeah, I think it's just chunks, if I'm not mistaken. So we don't need to run. Yeah, okay, cool. So it did work. So very elegant solution. Simple, straightforward, easy, fast. Yeah, but it's not the fastest. That's interesting. Exact 2, okay. repeat v1, take v0 as your size, collect I32. Yeah, actually flatten, and we can do here a flat map. That would be it. We don't need to kind of do anything else extra. Yeah, so we removed the step of flattening, which was losing some time, and we got first. Same, yeah. You don't need to repeat it even as this guy did here. So you just create a new vector, and that will be pretty optimal. Cool, we solved another one. Let's move on. Let me see, how many did we solve? Okay, so we are at sleep now. Async function sleep milliseconds. Yeah, that's that's a JavaScript one. Usually you do promise, resolve, reject. You do a set timeout. Inside the timeout, you'll have your resolve. Timeout you'll initialize with millis. Actually, you don't need reject in this case. Yeah, so let's run it and see, does this work? 4. Wait, we need to output something. We did output. How did we output this? Expected 1. Oh, okay. Expected. Wait, I don't understand. So we have a promise. Yeah, we need to return this. That's the idea. Yeah, more like that. Yeah, once you write a lot of Rust, I get confused with oh my god, so many solutions, and ours seems to be the worst one. Let's see what's the fastest. Wait, new promise, resolve, set timeout. I mean, it's exactly the same, so I do not get. So if I run it again, I'm pretty sure I'll get another result. Yeah, so this is random. So this is just a normal distribution of CPU. Sometimes work faster, sometimes less fast. Oh, not reliable though. Okay, so let's get into XOR or XOR operation. Define an array where nums I equal start plus 2 multiplied by I, and nums n equal nums lang. Return the bitwise XOR of all elements of nums. So n5 starts 0. Array num is equal to 0 2, 4, 6, 8, where we'll fold, start. Okay, so here it's an interesting one. Okay, so we'll have a range starting at 0. So first, in order to solve that, we'll create a range. So we start at 0 and we'll have n as usize. We need it to be as usize. So we have this range. Then start. So we can do a scan operation. Do we need scan or just fold? Yeah, probably fold will be enough for our case. So we'll have start. Fold will be start, and we'll have like accumulator and item. And item. I guess, yeah, we'll have, but this will not be mutable. And here we'll do okay, so first thing we'll need to define the values. So start 0, 5 elements. So let value will be so it will be like start. Yeah, I guess first we'll need to define the 0 index stuff. So we'll do it a little bit different. So we have this, and then we have a mapper function where we'll have start plus 2 multiplied by I. So every time start will be the same. So this will be like item or index in our case. And we'll have like start plus 2 multiplied by index. So we have the values. Probably we'll do this as usize as well. So we have our mapper. Then what we can do, we can just fold all the results. But yeah, I guess we can do skip 1 and then fold. We'll have start. We know that it starts at start always. Accumulator, item, and here we'll do accumulator, item. That's I32, I guess. Run. Item is usize. Okay, then we can do it the other way around. But wait a second, why do I need to do it like this? Why do I need to have it as new size? That's it. Yeah, so this was the entire solution. So using iterators, let's submit. Yeah, elegant, fast algorithm. XOR, rearrange products table. That feels like MySQL. Yeah, indeed it is. Change data type, apply transform over each element. Yeah, let's check this one. Maybe that's Rust as well. Yeah, that's JavaScript. Yeah, so given an integer array and the mapping function find, return a new array with the transformation applied to each element. Array map fn. That's kind of a, yeah, return. Confusing this. I need to return every time. Yeah, it's pretty easy problems. Yeah, same distribution. I don't feel like we'll have any other function. Oh. And that's faster than array map. A for loop. I don't know. I mean, weird. Very weird. Okay, I think we are good for the day. We managed to have a pretty interesting progress. Yeah, let's get to see how many problems did we manage to solve. Yeah, we managed to solve around 8 problems, including one medium, the starting one. So yeah, pretty good results for today. Yeah, thank you guys. Thank you everyone who joined, wrote comments, liked. Wish you a nice productive week, and let's hear in a couple of days.